Hello everyone. So today we start our new topic, inheritance and polymorphism. So you could even say that we're now really getting into the core concepts of object-oriented programming. So let me give you the translations for inheritance and polymorphism as I found them on Google Translate. So I should give some credit for that uh, in the hopes that this clarifies what these words actually, what the meanings of these words are. These are not just terms. Um, so let me begin by talking about some of the relationships that we have seen between classes. So far, there are actually two types of relationships we can have between classes. So far, we have seen only one type. The type that we have seen is called a has a relationship. Kind of like when you say the car has an engine, right? The engine is a part of the car. That's one type of relationship. And we've kind of seen that uh, in the sense that if we want to model this figure that we have in front of us here, a car and an engine, we could make a class called engine, and that could contain um, some member variables for that, like how many cylinders the engine has, how the size of the engine, how many cc's it has. It'll have its own constructor and maybe some other methods. And then we could have a separate class for the car. And the car will have its own methods, can have its own member variables, of course. And among those member variables can be an instance, an object of class engine. And so the engine specific information can be contained within this engine object, which is inside, which is of which we have an instance, an object inside the car class. So we have already seen that. For example, when we added a date object inside of a class, these are has a relationships. Another type of relationship that is possible is called an is-a relationship. Now, we have not used that in any of our small projects that we have done so far. An is-a relationship is slightly different. So consider this slide that you see over here. We have, for example, we have a whole category of vehicles. So on the one hand, we have a kind of a generic class called vehicle. And there are, of course, different types of vehicles. We could have a bicycle is a type of vehicle. A motorcycle is a type of vehicle. A car is a type of vehicle. A lorry or truck is a vehicle. So if we had 5 classes over here, let's say one class called vehicle, which contains methods and data members that are common among all vehicles, common to all of these vehicles that we're seeing over here. That could be one class. And then we could have separate classes for bicycle, a separate class for motorcycle, a separate class for car, and a separate class for lorry. And those could contain uh, data members and methods that only make sense for each of those vehicle types. Now, this type of relationship between the vehicle class, if we make one of those, and these more specific vehicles, bicycle, motorcycle, car, lorry, this type of relationship is called an is-a relationship. Now, we haven't done any project in which we've used this kind of relationship yet. So this today will be uh, our first day trying that. So the example that I'm going to show you today is actually going to use, instead of vehicles, because it's kind of easier to understand, it's not going to be a vehicle class and specific types of vehicles underneath. Instead, I'm going to use something a little simpler. I'm going to use this general class called for geometric shapes, Alishkal Hinsia. Uh, and then we'll have a couple of shapes underneath that, shapes that have a is a relationship with geometric shapes. And we'll also avoid rewriting a lot of code using something called inheritance that we can take advantage of in object-oriented programs. So let me take you to the starting point of this project and let's learn by doing. This is basically what we're going to make today. You can already see this is different from, uh, in one sense, this is different from many of the projects we've done before. First of all, each of these tables that you see over here, these should be familiar to you. These are UML class diagrams. The one at the top is for the class geometric object. And uh, this project is going to contain multiple classes. That's also not especially something new, but like I said, the relationship between these classes is new, the type of relationship that we will see. Now you will see that today's example will actually be a lot more code than what I'm used to showing you. So in order to keep the size of this video to a manageable length, I will be doing some copying, pasting in order to save time, typing time for this video. Already code is kind of already ready. So what we do is I already made a project. I call this one week 9.2. And instead of starting or doing anything in the main method, what I'm going to do is we are going to begin coding from the class at the top over here. You can see the other two classes are circle and rectangle. And you can already see the relationship between these classes. A circle is a geometric shape, a geometric object. A rectangle is also another type of geometric object. That's the relationship between these. Let me just walk you quickly through what's in the geometric object class. Among the member variable, we have a string that will store the color of the object, a Boolean variable that records whether or not the shape is filled out with that color. We also have a date object that will store the date on which the object was created. And underneath it, we have the methods. Of course, we have a constructor, no arg constructor. We have another constructor that takes a color, the color string, and whether or not the shape is to be filled out with that color or not as argument. Underneath that, we have pretty much what we expected: get color, set color, accessor method to access the color string in the member variable is filled, set filled, accessor methods for the filled member variable. Get date created is an accessor method to get the date from up here. And as you can see, it returns a date object. And we also have a toString method, which returns a nicely formatted string that prints out all of this information. So you can see this is pretty standard. Now, because the circle class underneath it has an is a relationship with the geometric object class, we draw an arrow from the circle class to the geometric object class, this red arrow that you can see over here. This arrow basically means that the circle class is a geometric is a relationship with geometric object. And so when since the circle class has an is a relationship with the geometric object class, means that everything that you see up here, all the member variables, all the methods of the geometric object class, can also be called for a circle object, because a circle is a geometric object. We will code it that way. We'll program it that way. But in addition to all of those things, a circle also has some additional properties. For example, a circle has a radius, which it stores as a member variable of the circle class. A circle has its own constructor, not one. In this case, we're going to see three, and we're going to have separate accessor methods for radius, get radius, and set radius. Um, Circles have area, which is computed using the radius. So we're going to get that using the get area method. We have a circle also has a perimeter, which is basically the length of the outside, right, of a circle. Get perimeter, get diameter, which is really just twice the radius. Um, and we have a print circle method, which in this case won't be doing much. Similarly, the rectangle also has an is a relationship with geometric object. Rectangles, however, don't have radius. They have a width and a height. So you can see, while all of these things all make sense for a circle and also make sense for a rectangle, the shape-specific member variables and methods are kept inside of the circle and rectangle classes respectively. So for the rectangle class, we'll also have three different constructors: a no-arc constructor, one that takes width and height, and another one that takes width, height, color, and filled or not filled status. We have accessor methods: get width, get height, set height. We have a get area method. Obviously, the area is computed differently for a rectangle than it is for a circle. So that's why the get area method is not shared in the geometric object class over here, but we'll get to that. So get area works differently for a circle and works differently for a rectangle. So that's why get area for a circle is over here, and get area, another method for a rectangle with the same name, is also in the rectangle class. And get perimeter, the perimeter of a rectangle is again calculated differently for a circle than it is for a rectangle. That's why both of these classes have their own get perimeter methods. So, without spending any further time, let's go to the IDE, and I'll start with the geometric object class, which means the first thing I have to do is I have to add a new Java class, and I'm going to call this geometric object. So create a new file. There you go. Okay. So first thing I have to do is let me see, what did we have over here? Okay, geometric object. So first, the easiest part. Let me just add these three member variables: a string called color, a boolean called filled, and a date object called date created. It's easy. Let's start with that. And like I said, in the interest of saving time, just going to paste these, and I'm also going to give these some default values. So if nothing is provided, color will initially be set to white. Boolean filled does not have a default. Well, default value is initialized to 0, and date created, yeah, of course. Okay, let's hop back. We have 1, 2 constructor methods: get color, set color, is filled, set filled, get date created. These are all very straightforward. Um, so let me jump back here, and let me begin, first we always do the constructors. So we have the no arg constructor over here. Should add comment. This, okay. So we have a no arg constructor. All it does is it puts a date into the date created date object in here. That's it. The second constructor takes a color and filled value, assigns those to the color and filled values of the member variable, and also initializes the date created object. So we're done with the constructors. That's all the constructors are going to do here. Okay. Typo. This is geometric object, not geometric object 1. Okay. Then we have a bunch of accessor methods. So first, get color returns color, set color takes the color value and assigns it to the member variable color. By now it should be masters in this stuff. We have another member variable called filled, and get filled, and is filled checks if filled is true or false. Set filled changes it to whatever value you provided in the argument. Finally, we had an accessor method for the third member variable, the date object, which just returns, called get date created, which just returns the date object date created. And in the end, what we wanted to do was we also wanted to override the toString method, and the toString method is going to print out return a string, not print it out, return a string, created on whatever the date created is, new line, color, whatever the color is, and filled, yes or no, true or false. And that's it. We're done with our geometric object class. Okay. So nothing new to see over here. We did not have to code anything differently from the way we've been coding classes before. So you can see, we were able to do all of this. We were able to write all of this code just by looking at this UML class diagram, using some common sense as to what the meaning of these accessor methods are, and of course reading some of these helpful comments over here that are describing the functionality of each of these methods. Okay, let's move on to the circle class, I guess. So the circle class, like I said, had three different constructors: get radius, set radius method, get area, get perimeter, get diameter. All of these values are computed using the radius, which is also a member variable, and finally a print circle method. Okay, so first of all, we're adding a new class. So new Java class called circle. Added. Okay. Okay. So jump ahead here. All right. So let me quickly do the. There's only one member variable of the circle class. Radius. We said we have three different constructors. A no arg constructor, We have a constructor that takes a radius, and we have another constructor that takes a radius and a color and a filled value. And remember that the color and filled values are not member variables of the circle class. They are member variables of the geometric object class up here. Let me introduce two more terms. So the circle class is called a subclass of geometric object class. Or you can say that the geometric object class is the superclass of the circle class. It is also the superclass of the rectangle class. Similarly, the rectangle class is a subclass of geometric object. So actually, before I go on, let me establish over here the relationship the circle has with geometric object, and all we have to do for that is add two words. There's one new keyword we're going to use for that. It is extends, and it comes over here from the same line where we write public class circle. We add after a space extends, which means the description of the circle class is adding to the description of the geometric object class. The addition of these two words over here basically establish this red line, this red arrow link that we here have. There is a relationship between circle and geometric object classes. That's it. That's what you add. By doing this, all of a sudden, all the member variables, all the member methods of the geometric object class are now accessible to me inside the circle class. And I need them right over here in this constructor. When I get color and filled values in the constructor of circle, I want to pass these on. I want to set these values in the geometric object. So to do that, you can see there's something new going on over here. Super and two arguments. What is this line doing? This calls the constructor of the superclass of the current class being circle. Now, which class is the superclass of circle? Geometric object. And if you go back to geometric object, you'll see that geometric object had a constructor method that takes two arguments, color and filled. We are basically, when we're saying super and we're passing it a string and a Boolean value, we are basically calling the constructor of the superclass, geometric object, and we're passing it these two arguments. And of course, this constructor with these two arguments has to be available, has to be present in the superclass. The radius value is just stored in the member variable radius of the circle class itself. Nothing new to see over here. You'll also notice over here in another constructor of, in this single argument constructor of the circle class, we're also calling super like this. I'll talk a little bit more about this in our next lecture, okay? But this is also a call to the superclass's no-arg constructor. So wherever it says super, you can, in your mind, you can substitute the name of the classes, of the current classes where you are. You can substitute the name of its superclass over here. In this case, geometric object. Okay. Moving on. the circle class had the accessor methods get radius, set radius. Let's add those quickly. There you go. Get radius returns radius, set radius puts a new value, assigns the new value of radius to the member variable radius. Okay, then we had the get area method. It's not much of a mystery. How do you compute the area of a circle? It's the radius squared, so radius times radius, multiplied by pi. And the value of pi very conveniently is available in the Java API as a constant in the math library, in the math class as math.pi. So this is the value of pi, 3.14 and so on. Okay, and just like that, we can have some other useful methods. In our case, we are required to add a get diameter method like this. The diameter is 2 times the radius, and also a get perimeter method, which is 2 times the radius times pi. Okay, perimeter or circumference. And there was another method called print circle. All it does is prints out some text, and being good citizens, we're going to override, also going to provide a toString method for the circle class, and we're done with the circle class. That's it. See, there was some new stuff, first of all, over here, establishing the geometric object as the superclass of circle, and there was this use of the super method, the super keyword in the constructors to call the constructors of the geometric object class, superclass. Okay, let's move on to the rectangle class. I'm going to add that just like I added the circle class. There you go. And before I do anything else, let me establish that this, like the circle class, is also a subclass of geometric object. Okay, so I'll go fast now. So rectangle had 2 member variables, width and height of type double. It has a no arc constructor that does nothing. It has a 2 argument constructor that takes width and height and assigns them, those arguments given, to the width and height member variables of itself. And it also has a 3rd constructor which takes width, height, but also a string color and a value for a Boolean value for filled. And now what I could do over here, I could do the same thing I did in the circle class. I could also easily call the constructor of the superclass like I did for circle up here, and I could pass it the value of color and the value of filled. I could do that. Then I wouldn't need these. But instead, I can also do it this way. I can simply call the setColor method of the geometric object class, which is rectangle's superclass. And after that, I can call the setFilled method of the geometric object class. And this will work just as well. Okay. One thing to remember, if you're going to call the constructor of a super method, of a superclass, using the super method over here, you have to make it the first line of code in the constructor. You can't do it at the end or in between. It has to be the first line. By the way, if you don't do anything, like in this version of the constructor, Java, when you compile this code, will automatically add this. It will add a call to the noarg constructor of the superclass. So whether I write this over here or whether I don't, makes no difference. It will, if I don't add it over here myself, Java will add it when I compile this code. So I might just as well add it. Same is the case over here. I can add a call to the superclasses constructor or not. Okay, so we're done with get width. Just like that, we have set width method. We have get height and set height. We add those. Really nothing to them, so I'm going to go through this quickly. Return width, return height, or get new values of width and height. And then we have the get area method. The area of a rectangle is calculated as width times height. Again, not much to it. And also have a get perimeter method, which is 2 times the width plus the height. Right. Okay. And we're done with the rectangle class as well. Okay. Now we still don't have anything in the main method. We're not using any of these classes, so let's add a main method. I'm going to do something fairly simple over here. So I'm first of all, let me create a circle object, and I'm creating it using the oneArg constructor, and I'm passing it an argument of 1, which is the radius in this case. So I'm creating a circle of radius 1. Okay, and then I'll just try out some of the methods we've made for the circle class. So for example, I'm going to print out the toString method, whatever that returns, the get radius method, the get area method, and the get diameter method. Okay, and I'll follow this up by something very similar for the rectangle. I'm going to create a rectangle object called rect1 with height and width, or width and height 2 and 4. Going to call the toString method on that. I'm going to call the get area method, and I am going to try out the get perimeter method. So that's a simple test program that will try out circle and rectangle classes. And let me try them out. Here you go. A circle, white, created on, which is So time right now, color white, filled, false. Remember, I did not provide any color or filled value, so white was, if you remember, the default value assigned to color in geometric object. Run this again. The radius, I set the radius to 1. The area is then 3.141, which is just pi, the value of pi, right? The diameter is 2, twice the radius. Makes sense. For the rectangle, just about almost the same time, exactly the same time. Color is white, filled is set to false, area is 8 because height and width were 2 and 4. 2 times 4 is 8, and the perimeter is 12. 2 times width plus 2 times height. Now you see that I actually just created a circle and a rectangle. I did not explicitly created an object of type of class geometric object. I didn't do that. Because circle is a subclass of geometric object, when you create a circle object, before you create the circle object is created, first a geometric object is created, and that is followed by a creation of a circle object over here. Okay, if I change the default value, actually let's check in the rectangle, I can provide color and filled values. Let me go back to the main method. So over here, instead of just providing height and width, I can provide color, let's say purple. I like purple. And default value for filled is false. If we provide a value true. So let's see how that works. Now I'm using a different constructor for rectangle, and as you can see, rectangle created with color purple, filled value is true. And these are both values that are stored in the member variables of the geometric object class, or that are actually inherited, that the rectangle class inherits from its superclass. So try this out a little bit. Okay. Let me just add a few words. So the superclasses constructor is not inherited. Instead, you have to call the superclasses constructor. You can either do it by adding that line of code yourself, which makes it an explicit call to the superconstructor. That way you can control, if there are multiple versions of the superclasses constructor, which one is being used. If you don't write anything, Java will add a call to the no-arg constructor anyway. So, up to you. Here's a slide that's basically explaining that if your code for a class A, which let's say is a subclass of some other class, if you put nothing in the constructor, like over here, if you leave it empty, that is the same as this. If you don't write super over here, your Java compiler will add that call to the superclasses no-arg constructor. Similarly, if you have some other constructor for your class A, let's say one that does take some arguments over here, and you have something over here, but you're still not calling the constructor of the superclass explicitly, Java will convert that into something like this, into exactly this. A call to the superclasses no-arg constructor, followed by all the statements that you put in your own class A's constructor. Now, another use of the super keyword is so one use we just saw, it's basically to access the constructors of a superclass. We also use the super keyword to access some of the methods of a superclass. Sometimes that becomes necessary, and we'll get to that case a little later on. So that's it for today, and I'll see you all tomorrow. Make sure you practice this. Um, uh, our class programming task will have to work quick because as we move on, especially um, in this section on inheritance and polymorphism, examples will typically involve multiple classes, which means there'll be more code to write, which means you have to work a little faster. So I'll see you all tomorrow. Have fun recreating this example and play around with it a little.